Hi, it's Alex from Rambler, a research unit dedicated to the application of machine learning in the field of meteorology. Weather and climate are hugely impacted by topography. Whether it's using deep learning model to forecast wind speed for big sports events or the inversion of precipitation via satellite images, adding the topography data of the study area can oftentimes boost the performance of your neural network and achieves better accuracy. So in today's video, I'm going to show you how to handle the basic topography data using Python, so that next time you can use them to better enhance your model. So when it comes to the topographic data, the very basic one is elevation, and it's often containing a digital elevation model, or a DEM. You could download all sorts of DEM from many websites, and here I'm at USGS, and I download one called GTOPO30. Which is a global DEM with a resolution of 30 arcseconds. You can see here it's in a TIFF file format. Kind of like PNG, it has graded values of elevation in columns and rows. And it also contains some geographic information for us to transfer it from columns and rows to actual geographic coordinate like longitude and latitude. So here we're going to use the GDAL library to do that. And it's pre-installed in Colab, I think. To load the file. I'm gonna copy the path here. The open function returns a GDAL dataset, which has a method called getGeoTransform. This method returns a tuple, contains 6 coefficients to help us do the transformation. I'm gonna print it here so you can see it. Okay, you can see the first one and the fourth one is the longitude and latitude of the top left corner of our TIFF. And this one is the width and height of every pixel in our TIFF. These two zeros, if we're using a north-south TIFF, they will be zeros, so don't worry about it. And now we're going to get the rows and columns of our TIFF. For R in range row, and for C in range column, we calculate longitude like this. And similarly, we calculate latitude like this. Just change to 3, 4, and 5. So now we have transformed columns and rows to longitude and latitude. We can cut our study area out. For example, here I've already cut out Central Asia area, and we're going to use this TIFF to further extract more terrain info using a package called RICHDEM. You need to install it. Here it's not pre-installed. To get the, like, for example, slope or aspect, it's very simple. You just use a function called terrain attribute. And DEM. Rise, rock. The same goes with aspect. Just change this to aspect. Okay, now we have these two. They are the RICHDEM. They're RICHDEM arrays, and you could just save them into NumPy arrays. To visualize them, we can import matplotlib. And rd show DM. Oh, here it should be slope and aspect at the end. Let's run it. Oops, what is wrong? Matplotlib pyplot. Sorry, typo here. Oh, so when we load the DM in RICHDM, we need to assign the missing value, so no data, and we assign it to 0. This time it should be fine. Okay, here is the slope, figure out slope and aspect. The slope is a rise-run slope, meaning it's the percentage of the tangent of the angle of the slope. And the aspect, if you're wondering what is this line here, I accidentally put them in the wrong order. You need to pull the upper part down. For example, if you put this part down here, you're gonna see the Caspian Sea, just like this. And that's it for this video. I'll put all the links down in the description. I hope this video is helpful. If you liked it, please give us a thumbs up. If you want to learn more about meteorology and machine learning, consider subscribe. And one last thing, if you happen to use BILIBILI, we already had an account there and have posted several videos on paper reading and hands-on tutorial on how to build a neural network. I highly recommend you to check them out by clicking the info card on top of your screen. Okay, that's about it. Until next time, see ya.